video, we're going to talk about solving absolute value equations, okay? But before we get to that, I want to talk a little bit about what an absolute value equation actually is, okay? Now, the geometric interpretation of an absolute value is actually, it is used to measure the distance between some number and 0 on the number line, okay? So, for example, if I said, what is the absolute value of 3? And the absolute value is denoted by these kind of vertical bars, okay? Well, the absolute value of 3 is 3, and the reason for that is that 3 is 3 away from 0 on the number line, okay? And if I said, hey, what about the absolute value of -3? Well, the absolute value of -3 is also 3, and that is because -3 is also 3 away from 0 on the number line. Okay, so that's what absolute value actually is. It's used to measure the distance between some number and 0 on the number line in its most basic sense. Okay, so that's what it actually represents, and that's why absolute values actually always turn whatever's inside positive. Okay, so notice the absolute value 3 was +3, and the absolute value -3 was also +3, because distance cannot be negative. Okay, and since distance cannot be negative, absolute values are always going to turn whatever is inside positive. If it was positive before, it stays positive, and if it was negative before, it becomes positive. Okay, so now that we know what an absolute value actually does and what it measures, I want to quickly go through a few of the more simple problems on how to solve absolute value equations. So I have 3 different absolute value equations at the top of the screen here. Okay, now the way you solve absolute value equations is actually fairly straightforward. Step 1 is to always isolate the absolute value completely. Okay, and what that means is I don't want anything happening outside the absolute value on that side of the equal sign. So for example, like let's say I had something like the absolute value of x plus 1 minus 3 equal to 7. Okay, notice how that -3 is not inside the absolute value, therefore the absolute value is not isolated. So the first step I would need to do is I would have to add 3 to each side. Okay, so sorry for the hard cut there. So in each of these examples, the absolute value is already isolated, and the reason I wanted to do that is because I want to talk about what each of these equations is actually asking for. Okay, because all of these equations are still asking for a distance. That's what this is still asking. Okay, all of these are still asking for a distance. But I'm going to get to that explanation in just a second. So, step 1, isolate the absolute value. We already have that accomplished in all 3 of these problems. So, step 2 is to set up your 2 equations, okay? And I know that might sound weird, but if you think back to the previous example, 3 and -3 both had an absolute value of +3. So, there were 2 answers. There were 2 numbers that had an absolute value that became a +3. So, we're actually going to have 2 equations here. You'll kind of see why. Now, I'm going to take a look at this green example first. Well, the way you set up your 2 equations once you have the absolute value isolated is the first one's just going to actually be a cut and paste job. X minus 3 is equal to 4. What's inside the absolute value never changes. Ever, 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 ever. It never changes, okay? So x minus 3 is equal to 4, but I'm also going to set up a second equation. X minus 3 is equal to -4. Because if this absolute value, if this x minus 3 is -4, well, that -4 would be inside the absolute value, which means the absolute value -4 is +4. So that's where the 2 answers come from. And then we just go ahead and solve each of these. So for each of these, I would be adding 3 to each side. I don't know why I skipped this one right here. We'd be adding 3 to each side to get x is equal to 7 and x is equal to -1. Okay, x is equal to 7 and x is -1. And now what these solutions are the answer to this equation. What this equation was asking for is what number or numbers are 4 away from 3. I know that's x minus 3, but we actually kind of think about it in the opposite sense, okay? You'll learn about that a little bit when we talk about transformations of functions, okay? But what this equation here is asking for is what number or numbers are 4 away from +3. Well, if we think about that, 7 is 4 away from 3, and -1 is also 4 away from 3. If you don't believe me, we can plot that on the number line here. We got -1 as an answer. -1 as an answer. I'm going to have to take marks. There's 7. And we got 7 as an answer here. Well, if we count this out, we got 1, 2, 4. That number right here is 3, and 1, 2, 4. That number there is 3 as well. So notice that -1 and +7 are both 4 away from 3. That's what this problem is asking for. That's why there were 2 answers. Okay. Now, this problem right here is also asking something. So notice this is the absolute value of x plus 1 equal to 0. Now, what this is asking for is what number or numbers are 0 away from -1. We take the opposite sign. -1. This one was what number or numbers are 4 away from +3. Well, this is asking what number or numbers are 0 away from -1. And if you can solve this without doing the equation, that's cool. If you can kind of read into what this problem is actually asking for and figure it out kind of just logically, that's totally awesome. If not, we can set up our, and in this case, it's only going to be one equation. Now in this problem over here, we set it equal to 4 and -4. Well, there's not a +0 and a -0. Okay, so we're actually only going to have one equation, and we're only going to have one solution of -1. That's because there's only one number that's 0 away from -1, and that is itself -1. Okay? So notice here how when this was equal to some number greater than 0, we got 2 answers. And when we had an absolute value equal to 0, we ended up with only one answer. Well, let's think about this one over here. And if we just actually think about what this is asking for, it actually kind of tells us what the answer is right away. What this problem is asking for is what number or numbers are -3 away from +2. Now that should make absolutely no sense, because I can't be like, hey, that Mario over there is negative, I don't know, 8 feet away from me. That doesn't make any sense. That's because distance can't be negative. So this is actually going to have no solution, okay? And say you didn't figure that out right away. We could go ahead and actually solve this. So let's say we would solve this. Well, we isolate the absolute value. It's already isolated. So I would set x minus 2 is equal to -3. Minus 2 is equal to +3. This is what I would assume my students would do. Right away, there should be a kind of red flag, because the first equation over here is equal to +4. This is equal to -3. You're supposed to change the sign to become negative. It shouldn't already be negative. So that should be a kind of dead giveaway. But if you didn't catch it, that's fine. Let's go ahead and solve these. We would add 2 to each side. Add 2 to each side, or I would assume I do this. And I would get x is equal to -1. X is equal to +5. Problem is, neither of those numbers are -3, because that's impossible. But some people will look at this and go, there's my answers. I got -1, I got +5. Total coincidence that -1 turned out in each of these, by the way. Just weird luck. Okay? But what you want to do after you get your answers is always to double check your answers. That's kind of step 4. Okay? The double check your answer. And the way we do that is we literally just plug these back into the original problem. Always the original. Okay? So if I plug -1 back in for x up here, -1 minus 2, the absolute value of that, that's equal to -3. So notice I just plugged -1 right in for x. So that would get me the absolute value of -3 is equal to -3. And from there, well, the absolute value of -3 is +3. And last time I checked, 3 does not equal -3. So notice it did not work. That's why it's actually not a solution. You would get the exact same case with 5. If you plugged in 5, you would once again get 3. -3, which is not true, which is why there is no solution. And you should always be double checking your answers. I'm not going to for pretty much all the examples in this video, just for time purposes. But if I wanted to, like real quick, let's say I wanted to double check 7. I would plug in 7. 7 minus 3, absolute value of that. I want to see if it's equal to 4. If I had to get 4, the absolute value of 4 is equal to 4. And that is true. 4 does equal 4. So you can always kind of double check your answers that way, okay? Now, those are some pretty simple examples. I do want to take a look at some more difficult ones. So let's go ahead and take a look at some harder problems. All right, so we got a problem here. We have the absolute value of r plus 3 minus 2 is equal to 5. Okay? Now, the first thing you always want to do, step 1, isolate the absolute value. So the first thing I would have to do is notice this minus 2 is not inside the absolute value, but it's on the same side of the equation. I got to get rid of that. So I got to move it over to the other side. You don't want to just throw it away. All right? Got to balance the equation by moving it to the other side. This is subtracting 2, so to undo that, I would add 2. Negative 2 plus 2 is 0. They can't. So this left side now is simply the absolute value of r plus 3 is equal to 5 plus 2 is 7. Okay, so now we have our absolute value isolated, and now we can kind of think about what this is asking for. We're asking for two numbers, or, well, it's going to be two numbers in this problem, but we're asking for what number or numbers are 7 away from negative. Okay, and you figure that out. Cool. If not, let's set up our equations. That's step 2. Set up your two equations. So one would be, and I'm going to do it kind of up here, r plus 3 is equal to positive 7. Because if r plus 3 is 7, then this would become the absolute value 7, which is 7, and it works. 7 equals 7. Or r plus 3 could get us negative 7. Because if r plus 3 got us negative 7, okay, that means this side would be the absolute value of negative 7 equals 7, and that is true because the absolute value of negative 7 is positive 7. Okay, so that's step 2. Set up your two equations if necessary. Might be only one. And now step 3 is we want to solve these equations. So I'm going to solve each of these. So the only thing I need to do is subtract 3 from each side. All I got to do is subtract 3 from each side. That's going to get me r is equal to 4. So r is equal to negative 10. Okay, got r is equal to 4 and r is equal to negative 10. And step 4 would be to double check your answers, which I'm going to leave you to do on your own, but I assure you that both of these problems do work. That's a slightly more advanced problem. Let's take a look at maybe one more that's even a little bit more challenging. All right, so we have a slightly more advanced problem here, and they really don't get much more complicated than this unless we start throwing in like radicals and quadratics and stuff inside of this absolute value, which we will not be doing. Okay, but this is about as challenging as it comes. We have 4 times the absolute value of 2c plus 3, then plus 1 is equal to 13. Now, the steps do not change. Even though this looks a lot more daunting, the steps don't change. Step 1, isolate the absolute value. So the first thing I'm going to do is I'm going to move this 1 over. So that was plus 1, so I'm going to subtract 1. So this is going to become 4 times the absolute value of 2c plus 3, now equal to 12. Okay? Now from here, your instinct might be telling you to distribute the 4 into that absolute value. Because, I mean, if it was a set of parentheses, you would 100% do that. And although you can distribute that 4, in my personal opinion, it actually makes the problem a little bit more difficult to manage. Okay? So what I would advise is get rid of that 4. That 4 is multiplying. You just said you would distribute it in. That's multiplication. Well, I can undo multiplication with division. So I can use this inverse operation of division to kind of just straight up get rid of that 4. I don't want it. Okay? So this is going to now become, the 4's cancel. So that's going to become 2c plus 3. The absolute value of 2c plus 3 is equal to 3. And now look at that. We have the absolute value completely isolated. So we move on to step 2, which is set up our two equations. I'm going to bring it here. That's a bad arrow. Whatever. All right, so our first equation is always the same. 2c plus 3 is equal to 3. Okay, and our second equation, the inside never changes. 2c plus 3 stays the same, but now we're equal to negative 3. I change it to negative 3. Okay, now we solve both of these equations. Our first step, subtract 3 from the side. And feel free to solve each of these separately, not at the same time. I'm doing it just for time purposes, but you can go ahead and do it separately, not at the same time. But if you do, you would get 2c is equal to 0, and 2c is equal to negative 6. So 2c is equal to 0, and 2c is equal to negative 6. And now, to finish it off, I'm going to divide each side by 2. 2 is multiplying. I want isolated, I want it by itself. c is equal to 0. Don't stress. For some reason, some of my students freak out when they start dividing 0 by numbers. You can divide 0 by anything other than 0. It's just 0. 0 divided by 2, 0 divided by 3, 0 divided by negative 1,000. It's just 0. So we get c is equal to 0. And then we get c is equal to negative 6 over 2 is negative 3. These are two answers. Feel free to double check these. That is step 4. You should be double checking these answers. But I want to end this video so it's not super long. So that is solving absolute value equations. If there's any questions, please feel free to ask me. I hope this video helped. And in the next video, we're going to be solving absolute value inequalities.